Thank you for the introduction there, Gloria. I think let's dive pretty much right into things here. Demirors, I think we'll start with you. We've been talking about spam a lot here, how the L2 space maybe differs from the L1. You wrote a research piece last year called MEV and the Limits of Scaling, highlighting how 50% of usage today comes with only 10% of the fees being paid. How do we get to this space? And maybe for people that aren't as familiar about the intricacies between L1 and L2 MEV dynamics, what are the key differences to highlight?
Fantastic question. Maybe to do a little bit of like a pulse. So who here is like familiar with MEV? Raise your hand. Okay, I don't need to re-explain too much. What about the concept of back running and atomic arbitrage? Anyone? Okay, a little bit less, but okay, cool. Yeah, so there's many different types of MEV you can think about. There's many different ways to extract it, to generate it, to like basically, utilize like, so there's a lot of like on DeFi execution primitives that people have set up, and they're all basically fancy ways of saying, hey, we've got a couple pools. They're not synchronized. How can I purchase some assets on one pool and say Uniswap, sell them on another pool on Aerodrome? So that's one type. We call that atomic arbitrage. It's called atomic because you can do it within one transaction. So you can actually do the swap on one pool, do the second swap on another pool, and if you don't make money, you can actually revert. On L1, this is very expensive to revert. You have to basically pay for the entire gas cost of doing all this computation, and then you revert, and you get nothing. If the congestion fees are very high on the layer one, then this is an expensive operation, right? It could be a couple of dollars. In the heat of things, it could have been a couple $100s. And so that's how you can think about atomic arbitrage on L1. And on L2, it's almost the exact same story, except gas is super duper cheap. And so these reverts can cost you about 1 cent when fees are low. And so if you're trying to do arbitrage, if you're doing an arbitrage that has, say, $50 of profit you find, well, you can try that a lot of frickin' times before you end up eating all of that $50 in profit in reverted fees. So yeah, I think that's the main way to think about it, is like the difference in the computation cost between the different layers. How's that?
I think that's a great way to highlight it here, especially given how DeFi was really the primary use case on the L1 there. Sanjan, I want to get your take on this as well. How do you feel about the current situation? How are you thinking about this as a PM?
Sweet. So I think Demirors has done a really good job at laying out the problem. Perhaps what I can do is add a L2 specific, or like talk a little bit more about like the L2 specific lens, right? So we work really hard to make the L2 cheap. And one of the unintended consequences, as Demirors highlighted, is that it is essentially free to be wrong. And so the natural filter that exists on an L1 that makes it important for a ARB bot to be right is pretty high, versus like a bot can spam hundreds of speculative transactions on an L2, and if like 1 in X hits, then it's profitable. And so really like the fundamental difference is the lack of, or between like an L1 and L2, is like the lack of a very specific auction mechanism that can like convert this thing called MEV into explicit bids. And so a searcher is inevitably going to end up spamming the L2 network in an attempt to place profitable bids. And so I'm quite excited to be working with Flashbots on this because I think like, you know, using Flashbots as research, we can actually convert this implicit gas spam into explicit Blockspace markets. Yeah.
I think you hit well on the research part there. Fahim, I think we want to bring you kind of into the mix here too. So MEV's definitely been very research-based historically. What are the challenges that we're seeing today when we look to bring this research that we've done into production on L2s?
Yeah, absolutely. So that's a great question. And I kind of like to start off with saying some of the work that I've done at Flashbots, where I was analyzing how we can, or researching how we can bring prop AMMs to layer 2 blockchains. And what a prop AMM is, it's an AMM where a market maker is able to push prices and get their latest quotes on chain. Now, on Solana, that's able to be done just like relatively easily because these writes, these updates are very cheap, and so they're able to go to top of the block at a very cheap price. However, on the other hand, on EVM chains, it's not comparatively as cheap. And so you have a situation where a market maker is able to be front-ran by a toxic or informed trader. And so some of my work at Flashbots was to kind of research, hey, how are we able to solve this problem? And the solution, or proposed solution, was being able to have a priority lane for these updates, such that you first have all the updates at the top of the block, and then what you have is the remainder of these like swap transactions and every other transaction after all these updates. But one of the problems with this approach and kind of bringing it into reality, as opposed to just keeping it as research, is how do we fend off against spam? Because when you have spam, you're going to have a lot of potential like market makers. They might spam up the entire block with all those updates, and then now there's less space for the remainder of the transactions on chain to land in that block, which poses an issue. And so, yeah.
Yeah, I think we definitely see that a lot where the gas limit for a given chain is increased, but then spam continues to take a lot of that net new block space that's been added.
Yeah.
Sanjana, from your perspective, when we're building our protocol, how are you thinking about what theories make sense to be implemented, what research is valuable, but maybe what your problems still are?
Yeah, great question. And I think like prop AMMs is like pretty top of mind for me. I'm very excited. I'd love to like talk a bit more about this after this fireside chat. Sorry, this regular non-fireside chat with you, Fahim. Okay, so there's three things that like stand out for me. And I'm gonna like put the perspective of which is like L2 versus L1, right? On L1, you have 12-second slots, which is ample amount of time to run a fair bid. On a lot of OP stack chains today, we effectively have 200 millisecond flash block times. And running a Blockspace auction in 200 milliseconds, which involves, doing the bid evaluation, network latency, ensuring there's like inclusion guarantees. All of that is like a really hard engineering challenge, right? So it's an order of magnitude more complicated than the L1. I think the other thing that is interesting to me is that with our focus on enterprises and like a bunch of different categories of enterprises, one size doesn't actually fit all. The Superchain is a melange of chains that have like a bunch of differentiated identity and ecosystem. And so chains like Base and Unichain are going to want to aggressively mitigate MEV for like high throughput DeFi, but chains like WorldChain are going to want to continue to prioritize verified humans over bots. Think about a payments chain. A payments chain is likely going to want to have fixed first come, first serve kind of transaction ordering. And so I think the definition of MEV itself is particular to the chain's use case. And so like coming up with a, converting like this sequencing stack into a programmable, configurable system is not as easy as like coming up with a very specific use case that we are really good at. So like just like going from a specific use case to a more generalized use case, or like a bunch of different generalized use cases is like, again, another challenge. And I think like the final one that I find the most challenging personally as a PM is like, how do you convert this techno optimism into actual hardened product, right? Which is like, there's a lot of cutting edge research that is happening. How do you convert all of that research into into essentially like a really simple configuration that any enterprise can like look at and be like, okay, these are the things that I can do, and now I have this like highly differentiated on-chain service that meets the demands and the needs of my users. So like it's just like, how do I make it really easy to onboard to? How do I make it really accessible? Like these are the questions that I ask myself again and again as I think about like MEV and just like differentiated block space across a bunch of different use cases.
Yeah, I think that's really interesting. We've seen the workloads, the type of chains we have continue to go in divergent directions, yet we have MEV as a core part of the protocol today. Maybe Demirors, I'll start over with you again here. So if we look at MEV today, it's a scaling problem, maybe also a scaling solution with some of the stuff you were saying there, Sanjana, but it's also revenue, and we're still in the revenue meta right now. How do we continue to evolve MEV in a way where economics also continue to make sense?
That is a very good question. It's in many ways we've been trying to answer this question for about 5 years, and we've gotten far, and I think there's lots of new insights. The way we like to think about it is trying to harness this competition for ordering rights to create optimal outcomes. And optimal outcomes is vague, but there is some intersection of like revenue for the chain, execution for the user, and also value paid to the arbitragers. The arbitragers are the ones capturing this MEV, and they are doing a good, valuable job for the chain. When they arbitrage two pools, now if you were to go through the unsynced, pre the arbitrage, you might get a worse price. Post the arbitrage, you now get a good price. So you should be rewarded for this. In many ways, it's an existential, moral question of like, I am the one that generated this transaction. Should I get all of the MEV? I think if you look at how the like PFOF and TradFi markets have evolved, they have a lot of regulatory structure and reporting standards for how you communicate this and facilitate these auctions. And so my hope is that we can progress into a world like that in blockchain, where we can sort of propose our own standards, self-regulate ourselves, and find optimal outcomes for everyone. Does that answer the question?
Yeah, I think it's interesting how you talked about like the prioritization and like what are the rules that ultimately define that as we move into MEV that looks a little bit different than just these initial trading use cases and 5 years of research with 50 years to go still.
Yeah, 50 years would be great. There's way more types of arbitrage as well. And I think to Sanjana's point, the specific chain the L2, the L3, the L4, whatever type of application you're deploying there will have different preferences for how this value is captured and redistributed. And so, ultimately some type of programmable layer where you're able to define these rules, define the redistribution would be fantastic. And I think this is just a little bit of a tangent thought, but I'm like greatly inspired by the work of like Google ad auctions, where, one of the key innovations there was like, hey, where the heck did you get this ad from? And so that is like, that is an input into the ad auction, and that allows you to redistribute the value. But I think these supply chains are much more complicated. You have an intent, which goes to an aggregator, which somehow, I don't know, meme coins are involved somehow. And then there's an Oracle update. And so who gets what and why and how is the eternal question.
I think that's a pretty complicated feedback loop that you just highlighted there. Sanjana, how are you looking at this as we're looking to build out the OP stack?
I'd actually like push back on the premise that like there is inherent tension between MEV and revenue. I think we've just like ended up in a place where we've kind of sort of gotten the worst of both worlds, which is MEV is like MEV, not MEV, but MEV spam is hurting scale. And the way that chains are extracting MEV today are suboptimal. And so, when you think about the different kinds of MEV, as like Demirors mentioned, there is harmful MEV, and the fact that L2, at least on the L2s, the mempool is private, means that things like sandwich attacks and front running are predominantly figured out, right? Like it eliminates that. Of course, with TEE-based attestations and like running this in cryptographically, you can prove that indeed the sequencer is not malicious. But there is no revenue to be extracted there, right? Like it is not in the benefit of the chain operators to actually extract more there. However, the neutral MEV, which is like what arbitrage and liquidations is all about, is actually really important for a chain from a protocol health perspective, from a price alignment perspective. And so the problem is not the fact that it is there, it's like how it's expressed. And so once again, with things like MEV auction, I think there is the ability to optimize for this economic value and in fact like actually generate more value because it's optimized. And then also with the effect of like it not hurting scale because now user transactions are actually going to go through because there's less spam. And I think like the final thing is honestly, it's like just like block space value, which is like how do we make it very easy for a chain operator to move from the notion of I am going to collect gas because these transactions show up to like intelligently auction block space off, right? Depending on the use cases that they're trying to bring on chain, how do they, using customized block building, how do they, price or generate revenue based on priority lane or like ahead of time auction, prop AMMs. There's a bunch of different things that you could be doing with that block space. How do you move away from like just PGA to something a lot more expressive?
Yeah, super great points. Something I wanted to double click on in the beginning what you were saying is so how spam affects users. Like, so in case that connection isn't clear, so yes, the chain is spammed, it becomes harder to use, but like in practice, what happens is, as I mentioned, you have $100 of arbitrage on the table. You can now try a lot of transactions. That makes it hard to get in, but not only that, you are actually giving away. If there is a competitive auction, and so the spam auction is competitive, but it is not like revenue maximizing or efficient in any way. What happens is people are trying to rush to get into the chain. This raises the base fee. Their potential profits from these arbitrages are going to the base fee. That raises it. Now all users of the chain are paying increased costs for just doing normal transactions. So yeah, I just wanted to double click on that.
Yeah, that's definitely like a scalability failure in many ways versus I think what Sanjana was talking about in terms of how more customization in the MEV space could lead to more value for the end user. How do we achieve that?
Totally. I also think there's like non-financial MEV. Like one example is like, this app XEN. Does anyone know anyone from XEN? I really want to meet them. But
we did invite them, by the way.
What's that? Okay. But this is like, somehow they're making money from it, but they're like incentivizing people to touch as much storage on the chain as possible, and now like it's harder for nodes to like to operate infrastructure. I think a token comes out of it, so it is kind of MEV. They're taking advantage of the fact that like storage is priced wrong across just all of Ethereum, and using that to create activity for a token. Anyways, that's another tangent.
Like, let's shift gears here slightly and go towards the cross-chain themes. So we're very focused on interop here at OP. We've been living in the cross-chain, omni-chain world for quite some time now. That trend only continues. Fahim, I'm going to start with you here. As we see more block space become more composable, are we going to see more of the same from MEV in terms of its linear growth, or are we going to see positive or negative sublinear growth?
Yeah, so that's a great question, and I'd argue that it's going to be super linear growth. And just to kind of first break down what a cross-chain transaction is, or atomic cross-chain transaction to be specific, because that's where a lot of MEV will come from. It's a transaction where it's between two different chains, and it's able to execute fully between those chains, or it doesn't execute at all. And so how that would look like in practice is if I see that like I'm able to buy an asset on chain A, I can then sell it on chain B, and do so like done atomically without it failing. Otherwise, it doesn't execute at all. But right now, in the current day, if you were to try doing that, you're going to have to buy on chain A, bridge to chain B, sell on chain B, and hope that the transaction happens all at once. Otherwise, you're going to have a partial transaction execution, where then you have to go back to chain A and sell that asset you bought on chain A, back at hopefully at the price that you bought it at, if you're trying to do an arbitrage there. So one of the ideas that this could be implemented in to kind of implement atomic cross-chain transactions was actually proposed by the Tygo team, where they were doing a lot of base rollups, in a sense where if you have a lot of these rollups doing their block building at the layer 1, you can then combine all these different transactions from all these different chains under the layer 1 and then propose that block across these different layer 2s as a way to have these cross-chain transactions that are then atomic. And so if you were to incorporate some sort of way to have atomic cross-chain transactions, you would get a lot of MEV that would otherwise not be unlocked between all of these different chains, and it'd be more than just linear.
While really giving that composable experience feeling like one chain.
We could repeat that last part.
But while giving that composable experience really feeling like one chain thanks to the MEV experience there. Demirors, what are your thoughts on this?
I do have some thoughts. My two things here: size, synchrony, antagonism, and Visa. I'll get to both of these. So size, synchrony, antagonism is this idea that Gavin Wood put forth in the Jam paper. I guess it's this new vision for Polkadot. But for me, it really frames how to think about interop. It would be fantastic if all the world's servers could all simultaneously, atomically, and synchronously execute with each other. But that's really hard to do. And so Gavin Wood proposed this framework where it's hey, if you were trying to make a coherent statement across two pieces of state, I know this is a little architecture brained. If you're trying to make a coherent statement across two pieces of state, then they need to be closer together. If you're the more state that you're trying to make coherent statements across, the more all of those need to be closer together, and that translates to them basically all running on more infrastructure that's closer to each other. And so you can think of atomic transactions as being the ultimate form of a coherent state. It's you want to make a claim on both pieces of state at the same time. So to me, this really helps me think about what are the limits of scaling an interop, and that we can't possibly fit all the world's state into one computer. And then this gets me to Visa. So it's ultimately, what are the incentives for doing interop? I think some years ago there was comments that oh, the L2s don't want to interop because, hey, set up a highway into my chain, but give me a dirt road out. I don't want my liquidity leaving. And I think Visa has the most interesting story that is relevant here, in that I'll skip a lot of the details, but there were a lot of banks that want to do business with each other and doing their own financial rails. And so instead they made a consortium, and this consortium was a non-stock ownership model. And so the idea was that you all use the same infrastructure, and based on how much flow you bring to the network, that's the proportion of fees that you get actually from the network. And so this is a way to try to make it incentive compatible. So I think probably some progression of these two ideas is what I find very interesting as an endgame for interop.
Interesting. Let's close things out here. One more question. We'll do this round robin style. Sanjay and I'll probably have you start this off. We've talked about where MEV came from, where it's going. Let's go back to that initial use case of it where it was being used for DeFi swaps. Today we have workloads that look very different. Are we still going in that same direction? What are the changes maybe that we need to make for these non-financial, non-swap use cases?
So I think that the tools are there, right? We've been thinking about different kinds of value flows for a while now, right? Again, I believe in chain sovereignty on the Superchain, and so I am very excited by the plethora of different kinds of use cases that coexist on the Superchain today. And I think we're going to, with OP Enterprise, we're going to, double down on that. We want to bring fintechs, exchanges, enterprise financial institutions on chain. And I think all of those different businesses are going to want to have their own business models run on chain. And like when I say they're going to have their own business models run on chain, it is going to practically mean that they're going to want to have their own different types of block building policies, right? And so when I say that the tool is already there, what I mean is the DeFi MEV era has given us engineering primitives, but the frameworks don't exist, which is we need to work together with these businesses to identify how would they want their sequencer, which is an extension of the business itself, to orchestrate this value flow. And again, we've seen a few different ways. World is doing top of block priority for humans. We're talking to Unichain about, and this is not specifically and directly related to just transaction ordering, but we are talking to them about just warm slots and SDM, using SDM for that, sequencer defined metering for that. And so I think we're just going to continue to double down on building a bunch of different frameworks that work well for different kinds of industries that we're about to bring on chain.
Demirors, anything you want to add there?
No, not much. I think you nailed it.
Fahim, any last words?
Honestly, that was pretty well covered. The only other thing I'd say is that, blockchains and just ordering, it all generalizes out to more than just finance. It's all about just state contention. Whether you have anything with even video games, for example, where you have multiple people shooting at each other, which bullet lands first, that sort of thing. It's just all state contention, and I think it's a really interesting problem to work on.
Yeah, I think how to optimize for contention is really the question. But I think what Sanjana highlighted there about bringing enterprises on chain and having business logic meet their needs, definitely the future direction that we're going in. Fahim, Demirors, Sanjana, thank you for your time today. Thank you for being here. And we'll hand it back from Gloria. Give him a hand.
Thanks.
Thank you.